right. So we're talking about how and why to teach computer programming. All right. And so I've been teaching computer programming for a while at a variety of different places to anything from junior high kids to college level kids. Also, I teach a lot of people. My day job is actually with a company called New Medio. I'm the chief nerd in charge there. And so I train a lot of our new guys. I do a lot of other stuff. Director of the Blythe Institute. We do independent research and education in intelligent design and other avenues of science. Organize technical conferences and lease microscopes to classrooms. I'm the owner of BP Learning and BP Books, and we do books and curriculum for homeschool and other nonfiction areas. My wife does educatingoaks.com, so she does a kind of a blog on how to manage your homeschool family. I'm actually working on some video curriculum specifically for computer programming. The video curriculum is going to be free. It's kind of going to be a summary of some of the classes that I do when I do computer programming classes. So these are some of my books. The one I'm kind of going to focus on here is New Programmers Start Here. I've done a lot of science, technology, and a few philosophy and theology books. So places to find me online. bplearning.net is the main site for our books. BlytheInstitute.org is for the research organization. My wife is at educatingoaks.com. You can also find me, occasionally I'll write for the Classical Conversation Writer Circle. And then I also blog on a site called Uncommon Descent. So, overview. Okay. Now, I have found that overall, homeschool families generally don't teach computer programming. And the reason for that is that, you tend to get overwhelmed in standard curriculum stuff, right? You've got math, science, English, history, all those things. And so what is the place of computer programming in homeschooling, right? So is this an elective? Do we have time for electives? Is housework our elective? Those are kind of the things that tend to crop up. The other thing is that few parents know how to program, right? So I was lucky. My dad learned programming in college. He taught me to program about the time I was 7. So I've been programming a long time, but a lot of parents don't know how to program, so they don't feel the need, or they don't feel the comfortableness in teaching their kids because they just don't know it themselves. And then also, it's often thought of as a job skill instead of a core subject area. Okay, and so they think, well, if my kid is not going to be, my kid's not going to be a computer programmer, we don't need to know how to program computers. Okay, but there's really good reasons why I think that this should be a lot more common and a lot more core of a curriculum than most people realize. First of all, computer programming promotes general thinking skills. Okay, this is we'll get into this a little bit. We'll go into this in a lot more depth, but there's a lot of areas that you literally can't find a better, more concrete way to teach logical thinking skills than computer programming. Software runs the modern world, right? So like a lot of things that we learn when we learn biology, not because you're going to be a biologist, but because we need to learn about how the modern world thinks about biology. We learn physics, not because you're going to be a physicist, but you need to have some basic background in education in the things that make the modern world the modern world. And so because everybody's got a cell phone, that means everybody walks around with a computer in their pocket. If you walk around with a computer in your pocket, you should know something about software. Okay. So almost every high school job in every industry is improved by computer programming. In fact, a lot of people come to computer programming kind of as a side part of whatever job they're in. They're like, you know what, I could automate this. And then they learn to program in order to automate something. Okay, so there's in every industry, they need people to program. Even if your job title is not programmer, you might wind up programming something. We need more and more quality programmers. A lot of this, we have people who were never taught to program. They start programming, and if they don't have a background in it, then you can sometimes run into problems. Um, so everybody, even if they don't start needing quality programmers, everyone winds up needing quality programmers. And then there's a lot of stuff in the news about software. Okay, people talk about software in the news. There's a lot of things like people say your website is insecure, all these sorts of things. And some of it's sensical, some of it's nonsensical. But if you don't have a background in software, it's hard to tell the difference. Okay, so just having a general software literacy, it might not tell you the answer to all those things, but at least give you the background you need if you're going to answer these things successfully. So the thing that I'm most interested in is actually the general thinking skills, because my wife and I look at homeschooling as a way of raising complete adults. Okay, and so the reason why we chose to homeschool is because we think that homeschooling, the schools may or may not teach the general subjects just fine, but they don't teach it to you as an integrated whole human being. And so I am actually most interested as far as teaching, as far as getting people to be whole people and have whole thinking. And most people don't realize that this is actually, they think of computer programming and philosophy as kind of opposite ends of the spectrum, but most people don't realize that computers were actually not invented to solve business problems. They were invented to solve a problem in philosophy. So basically, there were some logical questions that people had, and what they needed to do is define a rigorous way to define the word effective procedure, right? So do you have an effective procedure for doing this? So there's a problem in logic because people were doing proofs and they're like, well, is this proof really foolproof, or are they jumping some steps? And they didn't really know. Okay, so they need to find out what does it really mean to have an effective procedure to compute something. Okay, and so the actual whole point of computer programming is to very concretely define what it means when someone says, I have a procedure to do X. What does that mean? So they invented computers as a very concrete way of determining that. So to determine when a procedure you have given for a task is fully specified, right? Because if you can't fully specify it, the computer can't run it. Okay, and so it's like, in any subject, when you say show all your work, right? Well, in computer programming, if you don't show all your work, the program doesn't run. The computer can't get around you leaving details out. Okay, so if you have described something sufficiently so that it can be reproduced by anyone anywhere, you have to get to that point in order to describe it to a computer for the computer to run it. Okay, and so this, kind of a life lesson is you can tell if a description you're giving of a process is ambiguous or not. Okay, so if I give someone a task, being a computer programmer, I can automatically detect when I give someone a task where the edge details might be unclear. Because as having programmed a lot, I've realized, all the points where, if you say, well, charge your credit card for every transaction. Well, what if it's $0? What if they're getting something for free? Do they charge their credit card? That's something that sounds silly, but that's something that, if you're running a computer program, you have to account for every case. You have to be very specific about everything. But if you even just hiring people in business, you hire, someone off the street, you have to give them a full description of what they are supposed to do. And if you know computer programming, you're used to describing everything in full and not leaving anything out. So basically, most people think about computers as being smart, but computers are actually really dumb. And if you can describe a task to a computer, then you know that you understand the task yourself. Okay. In fact, that's one of the things that I like to do when I'm learning something new, especially if I'm learning, something new in physics or statistics. I'd like to program it because if I can program it, then I actually learned it. I know that I learned it. I'm not skipping any steps. I know 100% what it is to do it. There's no ambiguity, and I've got a complete process. So even if there's 100 programs out there, I'll be like, I just want to program this just to make sure that I understand it. Okay. And then there's general logic. Okay, logic is actually taught as a core subject in many homeschools. Classical Conversations has it as a subject, and but logic, formal logic itself, some people find difficult because it's abstract. Okay, there's a lot of rules, and you're not quite sure why the rules are there, and they're kind of hard to put together. The nice thing about computer programming is it's the same logical tools, but it's for very concrete applications. Okay, you can't. It's very practical. So if you ever read a logic book, they'll give, say, if P and Q and all these sorts of abstract things. Well, everything in your computer programming class is all concrete. It's like, if you went to the store and bought eggs, then, and so it's very, everything in computer programming it's the same logical tool set, but it's very concrete. In fact, one thing that I found that was kind of odd to me, but it makes sense, is I actually was giving this presentation, and there was a girl who'd gone through homeschooling, and she was listening to this. She said, I did not realize that there were practical applications of logic. And yes, computer programming is 100% a practical application of logic. And once you learn logic, if you understand logic, it allows you to think more clearly about every other subject. I love math, I love computer programming, not because of math and computer programming, but because of what it allows you to do. I tell people when they learn something new about math and logic, they haven't learned something new about math and logic, they've learned something new about everything. Okay? And so that's why it's so important as a core skill. And actually, if you this afternoon, my wife and I will be giving a talk on math as a core skill. And so I encourage you to come back and see that. So who needs programmers, right? So going back to the practical side, because people like practical stuff, who is it that's needing programmers? All right, so what do these companies have in common? You have a racing company, a housing company, a crash sensor for bike helmets, a drilling company, a manufacturing company, and a therapy company. What do they all have? And bicycle racing. What do they all have in common? Okay, they all rely on custom software for their daily operations. And so that's one thing. Almost every business, as it gets large enough, will need some amount of custom software. Okay, so now you're going to need programming, even if you don't do the programming yourself. So even if you don't do the programming, you'll need someone to do programming for you. And if you want to interact with them well, then you need to know something about programming. The people who don't know anything about programming, what happens is they don't even know what to expect. And even if you tell them what to expect, they don't understand it because they don't understand programming. And the people that I've interacted best with as a software developer are other people who've had some amount of programming in their past. Okay, so I can have a 10-minute conversation with someone who knows something about programming, and we can have a more productive conversation than 3 hours with someone who never has. Okay, and so it's just because it helps you understand what the process is, what sort of thoughts you have to go through, and someone who's never programmed before doesn't have any conception of those things, and it's a lot harder to get good information out of them because they don't realize how specific they have to be about the things that they need to tell you about. And anyone who's programmed before knows how specific you have to be about everything because they've had to do it. And so then they're like, oh yeah, you have to write a program, so that means you need everything, So I talk to people, and so I'll say, what's your process? And they'll give me the process. And so I'll have to go through that process, and if they've never programmed before, I know that I'm going to have to go through and ask them about their exceptions. And because people think that they have a very well-defined systematic process, but most of the people, like 50% of what they do is an exception to their process. And so they'll give you the process, and you say, are there any other exceptions, any other rules? They're like, nope, that's the whole thing. There's no exceptions, no rules. And they're like, okay, well let me come down and watch you do some of these things. You go down and watch them do it, and then all of a sudden, like, half of the things are, oh yeah, well that's something totally different. I'm like, well, if it's software, we have to account for all these things. And they're like, oh, I didn't realize that. And so if you've done software, you know you have this background information that you have to have all your ducks in order. And if you haven't had software, then this is a complete surprise to you. So anyway, and similarly, as I mentioned, we're not all going to be chemists, we're not all going to be physicists, we're not going to be geologists, we're not even all going to be writers, but knowing something about these subjects help us deal with our present age. And so it also just, once you know computer programming, it helps you interact with your device better, because you have a feel for what a programmer is going to do, because you kind of have a sense of what it takes to do something, and so you're more likely to interact with your program well. Every business is building technology strategies, and if you're going to operate at the strategy level in any business, you're probably going to need to interact with technology. And as I said, it's difficult to work with someone on a project if you can't even imagine what it is that they're doing on the other side. So the market for programmers, demand's increasing. I read a study that says that computer science is the highest starting salary. Now, this says $65,000 a year. I will tell you, in my company, we do not pay starting programmers $65,000 a year. This is average over the whole country, right? And we're in Oklahoma. So if you go to Silicon Valley, you'll probably start out about $65,000 a year. In Tulsa, not likely. But computing is about 70% of STEM jobs. So STEM is science, technology, engineering, math. Yeah. So and computing jobs are just increasing. And if you get good at it, you will never not have a job. Because there are a lot of people in programming who just try to skate through because of the giant demand. But if you actually decide to do it and love it, there will always be a job for you. And I'll tell you, the way that I figure out, like if you're wanting to do this not just as a core learning project, but as a long-term thing, what I would suggest to you is that the way that I find out whether or not I want to hire someone is based on the things that they do on their own for fun. Because if you're not enjoying it enough to have some side project, then you probably are not going to be the best person in the job. And the second thing is, have you used it enough to form opinions on it? So usually, while other people have people work problems, what I do is I ask them what their opinions are about the tools that they use, right? Because if they use something long enough, usually you develop opinions about how it could be better, or how you love it, or something like that. And what are the great things? What are the terrible things? And if you do something long enough, you usually develop those opinions. And if you're just trying to do it to get by, you usually don't. You just kind of do what's given to you. And then automation jobs continue in a down economy, because automation jobs make the productivity per worker increase. So in a down economy, people still hire programmers because that's what helps cover for lack of income. So then there's the deer in the headlights. You want me to teach programming, right? So now the first thing is that as a homeschool parent, you have probably already had to teach things you didn't know, right? And so first of all, you should just view this as something else that is along the lines of something that you need to learn yourself so that you can teach your kids. Okay? The one thing is that there are fewer resources geared towards helping homeschool parents. There's a decent amount of stuff towards kids, but not as much towards parents. And again, we're not trying to necessarily turn our kids into expert computer programmers. We're just trying to give them a foundational education. So we need to be open to learning new things ourselves. And if you're a homeschool parent and you haven't figured out that you need to learn new things, then I'm telling you now, you need to learn new things. So, and the basics can be learned without too much trouble. So here is a simple example computer program, okay? And so what it does is that what you do in computer programming is you define what are called functions. And functions are little building blocks that you can use to solve problems more than one time. Okay? And so we tell the computer that we're making a function, and we give it a name. Okay? And so so every programming language is different. This programming language is called JavaScript. Okay? So we have a function. It's called enough gas. And we're going to send this function 3 parameters. So these are 3 things that we're going to send to enough gas, and it's going to tell us if we have enough gas to make the trip. Okay, we're going to say how much gas we have remaining, the mileage we're getting on our gas, and the distance we're going to travel. Okay, and so what do we do? So first thing, we need to create a new variable, a new holding spot. Okay, so we create this new holding spot, the amount of gas to use. Okay, and that's going to be our distance divided by our mileage. And that'll tell us how much gas we're actually going to use on this trip. So then we say, if the amount of gas we're going to use is greater than the amount of gas remaining, then we're going to return false. So if the amount of gas we have to use is greater than the amount of gas remaining, we don't have enough gas. Otherwise, we return true. We do have enough gas. So then we have this function available, defined, that we can use anywhere. We can say enough gas. If I've got 20 gallons, I get 30 miles a gallon, and I'm going 500 miles, yes, we have enough gas. If I've got 20 gallons, 30 miles a gallon, we're going 700 miles, no, I don't have enough gas. Okay, so that's what computer programming looks like. Okay, and so it's very simple. You basically have to say exactly what each step of the way is. But once you do that, then the issues come into, we'll get into a minute, some of the things that make computer programming a little bit more complicated than other subjects. But as you can see, the basics of it are not horribly difficult to comprehend. So here's another one, the factorial function. If you're all familiar with factorial, 5 factorial means 5 times 4 times 3 times 2 times 1. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So that's the factorial function. So this is a factorial function. And so it's a function. We tell it it's a function, so that means I can call it as many times as I want. I name it, call it factorial, and then this is the name of the parameter you give me. You're going to give me a number. What it's going to do, it's going to start out with result as 1. And while number is greater than 1, say result equals result times number, and then we're going to subtract 1 from the number, and we're going to do it again. We're going to keep on doing this. See, we're subtracting 1 from number, and we'll keep on doing that as long as number is greater than 1. And when we're done, we return our result. So if I write this down on the board, when the first time through here, so I have number, and it's going to be 4. Okay, so number has 4 in it. Result has 1 in it. Okay, and it says while number is greater than 1. Is number greater than 1? Yes. All right. So we're going to do this part. Result equals. Now, equals in computer programming is different than equals in math. In math, if the equal sign says these two are equal. In computer programming, the equal sign says we're going to assign what's on the right to what's on the left. It's an assignment statement. So what is result times number? 4. All right, so it says result equals result times number. So that means we erase what's in result and put in what the answer was. Okay. Then I say number equals number minus 1. So what is number minus 1? 3. All right. 3. So we hit the brace. We do it again. Is number greater than 1? Yes. All right. So result equals result times number. What's result times number? 3. Result times number? 12. All right. So number equals number minus 1? 2. All right. So hit this, go here. Is number greater than 1? Yes. All right. So we're going to go through it. Result equals result times number. 24. Number equals number minus 1. All right. While number is greater than 1. Is 1 greater than 1? No. So we're done. So then we come out of here and we return result. Okay? So 24. So that is, so, I can tell you that factorial means 6 times 5 times 4 times 3 times 2 times 1. But that's not a step-by-step procedure. To explain it to a computer, you need a step-by-step procedure with nothing missing. Okay, and so that's the difference between programming and simply explaining something, is that if you program something, you need to know what the computer already knows and be able to describe it in a step-by-step manner that even a computer can understand you. Okay. So what should we teach? So I think we should focus on literacy over comprehensiveness, right? The main thing is not that you know everything about everything, but that you have an understanding so that anything that you want to learn later on is easy. That's so touching on many topics is more important than going deep into one. So I've kind of put together 4 things that I think that people really need to know these days. One is you should know some programming language, okay, whether that's JavaScript, C, C++, Java, which is different than JavaScript. If you ever say, oh, well, I've got a book on JavaScript and a book on Java, it's not the same thing. 2 different languages. So you need to know some programming language. You should know how the computer itself works. Okay? Something about how memory, hard drives, CPU, how those things interact. You need to know how computers are connected together through the internet. And this is important because the internet's everywhere. So everything that you do, we all get frustrated when we can't access the internet. And so the first thing we need to know is we need to understand how they're connected together, or we're not gonna, or we're just gonna have frustration rather than solutions. And then I think everybody needs to learn HTML, and that is the language of websites, because almost everyone is at some point going to need to edit content on a website. And so they have tools so that you can edit websites without HTML, but if you know something about HTML, that'll make the whole process a lot less mysterious, especially when something goes wrong. If something goes wrong, you can say, oh, well, if I know HTML, then you can at least have, you at least have something intelligent to ask someone about, rather than just saying, my website's broke, right? So, and as I said, it's okay if you don't know these things already. That's what books are for. So kind of in terms of the other way around, what you want students to be able to do, describe how computers process data, and they need to be able to write a simple program. And I just use this as an example. Write a program that adds a list of numbers successfully. And I think that's a doable job for most people. It doesn't take any special knowledge. You could do that with any programming language, but if at least get to the point where you know enough about programming that you can add a list of numbers together successfully. Write a program that takes user input and uses it for computation. So you know something about how to get data from people. Okay. Write a simple web page, and then be able to describe how the computers are located and accessed on the internet. Okay. Now, programming brings with it some specific challenges that you don't have in other subjects. Okay. So one of the big things about programming is that small errors completely break programs. All right. I just a couple days ago, I accidentally my computer science professor always told me, if you haven't tested it, it doesn't work, right? And that's 100% true, but I didn't follow his advice. I added a line to a computer program and I didn't test it before I pushed it live. And I left off a comma, and the whole website went down. Broke the whole thing. Now, not all websites are quite that integrated, but in this case, I pushed the change. The whole website went down because I missed one comma. So, so that's one of the difficulties with programs, especially if it's your first one. You're like, something's broke and I don't know what it is. And so trying to ferret out, like even if you have the program in front of you that you're supposed to type out, recognizing that you missed a comma, or you put a semicolon instead of a comma, or it asked for a semicolon, you put in a comma, or you put in the wrong quotes, you wanted double quotes, you put in single quotes, or something like that. Small errors can really break you, especially early on. Okay, so that's one of the, and then getting set up is actually one of the hardest tasks of computer programming. Like when now, the book that I wrote actually aims at trying to get you to program just with the tools that are already installed. But I'll tell you, when we have a new programmer hire on, we actually spend about a day or two getting their computer set up to do programming, because getting set up, in 100% to go is actually pretty difficult. So these two are why it's sometimes hard to get into programming, because if you don't know how to set up your computer and everything breaks the first time you try it, then you're like, what do I even do, right? So those are difficulties that are specific to programming. The other thing is that there is no one right answer. I can write that factorial program in about 10 different ways, all about the same length, and all resulting in the correct answer. Okay, so unlike I submitted my book to one resource organization. They're like, well, we really want a book that has fill in the blank answers. Like, well, you can't really you're not programming if you're doing fill in the blank answers. This stuff, it's about taking an idea and generating a sequence of instructions. And each person is going to have their own way of doing that. And the other one is that computer error messages are very difficult to comprehend for new people. Okay. Now, I actually, having done this for a while, I'm very good at reading computer error messages. And sometimes, just kind of as a side note, a lot of people who ask for programs to be built ask for very nice, friendly error messages. But I will tell you that nice, friendly error messages are actually sometimes counterproductive, because when a computer encounters an error, the computer doesn't actually know why there's an error. And so if you try to get the computer to guess why there's an error, you actually wind up pointing people in the wrong direction. An example of this is I used to do tech support way back when Windows 95 first came out. Okay, and Windows 95 was trying to be helpful. Okay, so like you might have gotten some weird error that says about not being able to find a website, and you're like, I don't know what that means, right? Well, what they tried to do is, at that time, that was when we had to dial up the internet on our modem. Now, the most likely reason at that point in time for you not to access a website is because you forgot to dial in. But what Microsoft did is they're always connected because they're Microsoft. So the people who wrote their software said that, well, probably the most likely reason is because their internet service provider is down. So the message they gave was, we couldn't contact this website. Please contact your internet service provider. So every time someone couldn't access a website because they forgot to dial in, they would call us. I said, well, the computer told me to call you. I was like, no. and so this is, so sometimes when people ask for helpful error messages, I'm like, I'm not sure if you really know what you're asking for. Because usually what you're asking for is to give people bad advice. Because computers are you don't want to get advice from a computer. They're usually wrong. You give the computer advice, it doesn't give you advice. And so I like the cryptic error messages because it's as much as the computer actually knows about what's wrong. So they're a little harder to understand, but the computer's at least being truthful with you about how much it knows, right? So on the other hand, there's a great benefit to computer programming is there's no question as to whether the answer is right or wrong. The computer program will work or it won't, right? So like, sometimes you say, well, you need to show your work. Well, in computer programming, you only show your work. If you didn't show your work, the computer wouldn't run. So my recommendation is that you find a person or a group of people who will simply help you through your first couple of computer programs. After that, it's not so hard. But the first couple is where you really struggle. And once you can do that, then it's no problem at all because you recognize the things that you need to be looking for. Okay. So here's the resource that I put together on this. It's called New Programmers Start Here. And it's based on several courses I've taught, largely on co-op classes that I've taught with homeschool families. And so a lot of those background issues, the first half of the book spends time covering the background issues. In fact, the first half of the book doesn't even get into actual computer programming. It just gets into how are computers connected on the internet? How do computers talk to each other? What does data look like? How does the computer process things? It's actually, interestingly, a Christian perspective on computer programming, which you might find that odd, but how would you have a Christian perspective? But there's a few things as far as, and there's not a lot, but there's a few things as far as, whether or not you can actually have true artificial intelligence through computing. Now, that's actually one of the topics that I find interesting. I don't put it in the book, but I've, for really, really advanced stuff, if you're interested, I have a talk called Solving Engineering Problems Using Theology, which goes into how to, what Christian theology has to say about computer programming and how it can benefit computer programmers. But as I said, it's kind of a technical talk, so if you're not into that thing, I wouldn't worry about it. It's got activities, it's got reviews, it's got questions for students. I've got a reader forum, and then I also have an upcoming series of videos to walk you through the book, especially the next that so I got the first video up, and the next couple I'm going to do is on what you need to do to get your computer set up. Because most of it is like little tweaks, because your computer is usually, they gear computers towards people who don't know what they're doing and trying to remove details away from people that they don't need. And that's one of the most confusing things about computers is extra details that you don't need. But computer programmers need the details. So there's a lot of settings that you need to set on your computer to tell your computer to give me all the details. So I don't know if anyone noticed this, but over the past couple decades, Microsoft Windows used to give all of your documents extensions like .exe, .doc, .docx. Those extensions are still there. They just hide them from you now. So one of the things is, how to get the extensions showing again, right? And so just some things that you need to do on your computer. The other thing is, like, sometimes when you're typing, the computer will automatically convert your straight quotes to curly quotes. If you've ever seen where it does on the edges of your words, it will curl into your words, right? Computer programming languages hate that, so you have to turn that off. So a lot of the little things that they've done, you just have to know what to turn off and what to turn on, because if your computer throws in curly quotes, your program will break. So anyways, that's the. Hopefully in the next week or two, I'll have those videos up for figuring your computer, because that's one of the weirder things. And so, but I'm gonna have a video series going through the whole book. Yes.
So we've been talking about this for years, Jonathan.
Yes.
David is finally old enough for this.
Yes.
Getting your book with a mother who knows nothing.
Yes.
And between that and the videos, and I don't know, since I have your wife's phone number, calling you in desperation, is that enough?
I think it is.
For a 12-year-old, he's 12.
Yeah.
Is that enough?
Yeah. Especially so. Once the videos themselves, I think will be a huge benefit, because that's where all the weird things. Because I tried to put some things in the book as far as how to what you need to do on each computer, but there's some things that are kind of like I can't point to you exactly where the menus are, but I can do that with a video. And so that's one of the reasons why I decided to put the video together. But I actually think that'll wind up being more than enough. So the big thing is just, if you get stuck on a program, call someone who knows how to program. Just say, here's the program, what's the problem? And any programmer that will be able to identify issues that you have right away. Because I can tell you, I've been programming for a while. Even if I don't know the programming language, I can usually look at a computer program and point to the errors. And so especially for simple programs like these are focused on. If you know anyone who knows anything about it, and you can actually find my email on my website. So if you have any problems, you can email me. And
My
that's
brother's a programmer too, but he's probably more impatient with me than you would be.
yes.
So I was listening to Glenn Beck radio,
Uh-huh.
and he was talking about like the artificial intelligence, whatever. Like,
Mhm.
how does that work? Like he
Yeah.
was saying that like they had a little hard drive, and you just plug it in.
Yeah.
All goes in there.
So okay. So as far as artificial intelligence goes, there's artificial intelligence is not actually possible, and that was actually deduced. The very first papers on computer science by Alan Turing actually proved that you can't do artificial intelligence, but people don't bother to read that. They're very excited about the idea of mimicking the human mind. So but what people do is what's called artificial intelligence is usually just really advanced computer stuff like computer vision, which is looking at a scene and face detection and that sort of thing. That's considered artificial intelligence. Natural language processing is considered artificial intelligence, but people use the words artificial intelligence to mean just about anything. So in fact, that's kind of a marketing gimmick to some extent. Just anything that you do is artificial intelligence. And my boss and I have been joking about just renaming all of our current projects to be high machine intelligence and then the name of the product. And anyway, so there are some things that tend to be considered artificial intelligence that are kind of in that field, as I said, computer vision, natural language processing, there's automated learning, which isn't as automated or as learning as you might expect from the name, but things like that, and those exist. Now, are you talking about something that just automatically copies itself in, or?
Somehow they put it in like your brain, and you can, I guess, kind of.
I think there's been ideas of people doing that, but what they have been able to do is, I think that just like you can have an implant of anything else, you can have implants that I don't know as far as what they've done, but I would expect them to be able to do just about any technical thing, interface with your retinas, interface with your whatever. But you could get something to think for you if you figured out how to activate it, but you couldn't get it to. The one thing computers are not creative, so you couldn't get them to create for you. You could get them to process for you.
So setting aside HTML, we already talked about that.
Mhm.
If you were going to pick one computer language to teach, what would you recommend and why?
So I recommend, so the book focuses on JavaScript. And the reason for that is not because JavaScript is a great language, but it's because it's everywhere and you already have it on your computer and it's already useful because you use it in web pages. So that's why I teach JavaScript. Now, as far as being a great language for teaching, I would say, probably the best, and it kind of depends on what you're trying to teach. The best language for teaching computer programming as a skill is probably Java, not JavaScript, Java.
Well, let me expand the question.
Yeah.
So I've got a 14-year-old.
Mhm.
He seems interested in computer-related stuff as a potential career.
Okay.
I want to start him in something to see if he lights up, right? Or if that's not really his thing, and then we go.
Yeah. So seeing if someone lights up, I like JavaScript for the reasons I said, that it's already on your computer. There's not, and then there's also, there's a lot of people. There's kind of a large group of Minecraft programming stuff. And I haven't really gotten into that, so I don't know. I don't know the details on that sort of stuff because I'm kind of old school. So those things also might be helpful. But I like to do JavaScript because any amount of JavaScript that you learn is going to be helpful. And
So we tried one of those Minecraft
Mhm.
computer programming courses, don't waste your money.
Okay.
Okay.
And basically, they're teaching them to cut and paste code in
Yeah.
to do things, and they don't actually learn. My son, about a third of the way in, like, Dad, I haven't learned a thing except how to cut and paste. And I explained why the code does what it does.
Yeah. That's
So I wasted $120.
that's what I've found with a lot of things like that. I have an aversion to things that, and I call it not teaching. It looks like it's teaching, but it's really not. And I just, you can, those things are helpful in the sense that they can get someone excited about it, but they're not helpful in the sense that to actually teach somebody to do something.
David started using that Scratch program,
Uh-huh.
and it's neat to kind of get a feel for it, but it doesn't take you long to kind of be like, now I'm bored.
Yeah. Yeah. So.
So you prefer JavaScript over C or C++?
Yeah, so as I said, it depends on why you're wanting to learn. But as a starting language, C is really good if you want to learn how the machine works, because it's much more closer to a machine. In fact, my first programming book I wrote is called Programming from the Ground Up, and it's based on what's called assembly language, which is the language of the computer itself, right? And the reason that I wrote that is because I was tired. I worked for a company called Wolfram Research, and I was hiring for the web group, and I was tired of getting graduates from computer science programs that didn't know how the computer worked. And so I wrote a book that was, because if you can't learn assembly language and not know how the computer works. And so I wrote a book that's like, well, if someone at least just starts here, then they can have a better understanding of what the thing is that they're actually going to school to learn. And so as I said, it depends on what you're aiming for. If you want to dive into be more on the electrical engineering side, then C, assembly language are kind of the places to go. Programming as a career, Java is probably the most clean. This is the way that you're probably going to do it in a lot of other languages. Type of a language. So there's certain JavaScript. One of the problems with it is that it's some of the more advanced things are really kind of strange on it. And so you've got the basics. It was actually meant to be a very easy beginner language, and it is. But when you jump from beginner to intermediate and advanced, JavaScript gets really weird. But Java by itself is actually very clean all the way through.
Right, because my understanding is they're getting away from JavaScript and going more towards Java.
It's actually to some extent the other way around. Which I have opinions on that, but they don't really matter. There's nothing that's going away from JavaScript on the web.
Okay.
As far as the web goes, pretty much any interactivity that you see on a web page is there because of JavaScript. And that's not going to change. If it changes, it will be at least a decade away. So
have you done anything with, like, the next step, like how to use any of the small devices like Raspberries or?
Oh yeah, so I actually I run Tulsa Open Source Hardware, which focuses on basically Arduino and that sort of thing. In fact, at my booth, I've got an electronics starter kit. It doesn't have an Arduino in it, but I actually have more advanced kits elsewhere that do have them in it. So I've got actually the Stem Cell downtown sells some of my kits, and so they can. And then I also sometimes run an electronics class. So if you sign up at my booth put your email address, I'll let you know when we're doing those. The electronics class includes doing Arduinos. We don't do Raspberry Pis. Raspberry Pis are cool, but they're just computers. I mean, the Raspberry Pi is a computer. You can run Windows on a Raspberry Pi. So they're nice because they actually have they're tiny and they have direct electrical output pins, but they're not really any different from a regular computer.
Because that's one of the big I'm not a programmer, but I have programmers that work for me. So,
Mhm.
and I see by the way, your kids are half decent programmers coming out of college, but they're U.S. born and can get a really high security clearance.
Mhm.
We hire them left and right. If they're really good programmers that have a high security clearance, they can name their price. Serious. We can't find them. We can find guys from China and everywhere else that go to our universities that are great programmers, but U.S. born ones, we can't find them. So, just for future job opportunities. So anyway, like I'm more of an engineer kind of guy. I can't write very well, but I can find 50 people in Tulsa that will teach my son how to write for a certain fee. But I can't find, there aren't programming tutors left and right that I've found. So I'll come see you booth and all your stuff.
Awesome. All right. Well, thank you all. I
Thank you.
appreciate it. And I'll put this talk on my website if you want to refer back to it. So go to bplearning.net. You can listen.